So here's my problem. I've got 4 charges that are all the same magnitude, and I need to find the net force on the negative charge, right? So the problem doesn't have it drawn out, but I've drawn the problem out here, right? That's always the best thing to do first, is draw it out. So it tells you that they're arranged in a square, right? So I've drawn my 3 positive charges here and my negative charge down here. And I've labeled the charges 1, 2, 3, and 4. So that way make it easier to solve, right? So this is my negative charge. I want to find the net force on this negative charge. So I'm also writing down what I know. I know that Q1, Q2, Q3, and Q4, the values of those charges are all 11.41 microcoulombs. And I know the distance between them is 91.7 centimeters. That's each side of the square, okay? So let's go solve. So first, right, anytime you're doing a problem with forces, first thing, got to draw the vectors, right? So let's label what forces there are. So the positive charge here and the positive charge here are both going to be pulling along those sides of the square, right? So I'll call this the force from charge 2. I'll call it F2. And I'll call this one F3 for the force from charge 3. And then there's also charge 1 over here that's pulling, and I'll draw it right here. But this is going to be smaller because it's further away, right? So I'll call that F1. Okay, so now before I start doing vector addition, let's go solve individually for each of these forces. Okay, so first let's do F2 and F3. So I know that F2 and F3 are equal to each other because they're both the same distance, right? All those charges have the same magnitude, so these two Q's are both the same, and the R's are both the same, right? So I'll just solve once and then be able to plug it in twice. So for those two, the force is KQQ over R squared, right? And because both those Q's are the same, I'm going to call it that. Okay, so if I go plug in, I get this, right? So notice I've substituted this in base units, microcoulombs, I've converted to coulombs by multiplying by 10 to the minus 6th, and I converted my centimeters to meters by moving the decimal back 2, right? And so if you do this, you end up with 1.39 newtons for F2 and F3. Okay, so let's go do F1. So F1 is the same concept, right? But now I can't use the same R that I used before, right? Because in this case, R is this whole distance across the middle, right? But luckily, this makes a 45, 45, 90 triangle, right? And I can solve for what R is. So in this case, I'm going to call this L, right? So I'm going to change this to L, just to make it something different so I don't use R. So if I'm solving for L, I can use the Pythagorean Theorem to figure that out. Right, so L squared equals R squared plus R squared. So L is going to equal 2 of 0.917 squared, right? So it's 0.917 squared plus 0.917 squared. So if you do this, you get R equal to 1.297 meters. Okay, so now I can take this and plug it in here. When I do that, I get this, right? I've converted again, and I've plugged in this squared, and that gives me 0.697 newtons. Okay, so now I know F1 and F2 and F3. So now I can draw my vectors and solve. All right, so let's solve this by adding our vectors, right? So I'm going to draw them over here where it's easier to see. So I'll start with F2, and then F3 points this way, right? And notice how F1 is going at an angle. So as soon as I see that, I know I have to break F1 into components. So this F1, right, is going to get broken into, if F1 looks like this, F1 needs to get broken down into an F1 in the X direction and an F1 in the Y direction. Okay, so I'm just going to go ahead and draw my components on this. So F2, and then I'm going to draw F1 in the Y direction, and then F3, and then F1 in the X direction. And so I can see that my resultant is going to point this way, right? That's going to be the sum of those. So again, it's making a 45, 45, 90 triangle, right? So this is really not that complicated to solve. So let's just go plug in, and then we can use the Pythagorean theorem, right? So let's get all my y's first, okay? So y is going to be f2 plus f1 in the y direction. And over here, right, remember these two components? I'm just going to call this one my 45 degree angle, right? So when I break up f1 into the x and y components, because it's at a 45 degree angle, either one of these is just going to be times sine or cosine, right? And because it's 45 degrees, they're both going to be the same. So I'm going to call my x my cosine. So f1 in the x direction is going to be the cosine component, and y will be the sine component. So this will be f1 sine 45, and this will be f1 cosine 45. So I'm going to bring that over here. So that's f2 plus f1 sine 45. And so when you do that, f2 is 1.39, and f1 is 0.697, so plus 0.697 sine 45. Right? And so when I do that, I get 1.88 newtons. Okay? And so you could, if you wanted to, you could go solve for the x direction too. Right? So I know this right here is 1.88. That means that this side also has to be 1.88, right? So I could go do, if I wanted the x direction, it would be f3 plus f1 cosine 45, right? So this is f1x, but that's coming here. I could do that, but I know it's got to be the same because this is a 45, 45, 90 triangle, right? Because of the fact that this is a square. So this side also has to be 1.88. So if I know this side and this side, I can solve for the hypotenuse, right? So this is my net force, right? So the net force is going to be equal to the square root of the two sides. Oops. The square root of the sum of the two sides, right? The square root of this side plus the square root of that side. Sorry, square root of this side squared plus that side squared. And when you do that, you end up with 2.66 newtons. Okay? So it wasn't a complicated problem, but you have to take this force. First, you have to figure out the distance to solve the forces, right? It was easy because all the magnitudes were the same. You go plug that in, you get the two forces, and then you do vector addition, right? Break this one up first into its two components, and then you add all the y's and all the x's, and now you have a triangle, and we can use Pythagorean theorem, and then we get the answer.